Thank you. I'm Isabella. I'm the tech lead for this tool, Machine Learning Inference Advisor. And today I'm going to speak about the story of MLIA. Okay. The journey from all the bits at Mercury in school. But my talk is not going to be anything about, for example, training. That's not accuracy. We don't talk about it. It's going to be about the tools, exactly. When I joined ML in a few years ago, the age we were in, it was really a cloud era age. So I really started with send an image on the cloud, get the inference done. Yes, it's a cut. Get back to the user, it's a cut. What actually AGI means in the time that can now, it means that we have to deploy on a fragmented, so we have CPU, NPU, GPUs, it will come also heterogeneous SoCs. So all the thing that makes hard AGI, so constraints, latency, memory, bandwidth. What can go wrong? You have to do many steps to get it right, basically. And actually, I'm tidying up with the internet map before. Inference now doesn't live just in one single place. What does it mean? It means that when we started, it was on cloud, you have your own machine. Now we have inference in AWS instances. We have heard just seconds ago. We have IoT devices. We have our phones. We have accelerated tablets. So the same model can run on different hardware, with different behavior, of course, and with different constraints. That's where MLI come in. I like that phrase. Portability of models is not a proprietary performance. So wherever you go, the model will behave differently. This is our vision. MLI is really a tool to early insight into inference in production. What does it mean? It means that we make ML be a visible area. I will show you a couple of slides what it means in the training pipeline, and actually I will have a demo after. It means that we turn our constraint from a point of that comes later. I have done already my training. I have deployed the model. Oh no, it goes wrong. Oh no, it takes too long. I'll take those problems back early and I will identify them. We replace surprises that oh no into informed decision. And it's just in a matter of couple of comments. So what does it mean? Less failure. And yeah, you can check different IPs just with a couple of comments. What it is, MLA, what is not an runtime, is not a benchmarking tool, is not a model optimization tool, and not an accuracy evaluation. We have lots of brothers and sisters that does amazing job on that. We are not. What we are, a decision support tool for inference, is basically something that helps you to decide, oh yeah, we go run okay or not. As I was saying, it complements existing machine learning tools, is reduce integration and friction, and mostly is repeatable. So every time that you do the check, what we will see later, on a model, you will have the same answers. Using the same sort of pipeline just in the previous talk. Historically, it's train, gather the data, train, optimize eventually, and deploy. At deploy time, you will know if that's okay or not. We come in the middle. So MLIA does compatibility and performance checking. It gives you some insight. So just performance checking, it means something. So you know how much it will take, for how much cycles it will take. And it gives you also a bit of advice. You can go apply your own optimization and retry again. So on the same optimized model and see how it goes. It has a lot of different things that we can spit out. So unsupported operators, visualize bottlenecks. So we can see if there is a operator or a chain operator that are not okay for the specific target, it will say, oh yeah, have a look. A bit of story of MLA. It started with ETOSU MPUs. Mostly Italy was the first ARM for accelerator for machine learning. It's really tiny. It's on the IoT side. That's why I always say that it's unforgiving, because either it runs on EPSU or it doesn't. So all the operator needs to be supported, and there are tools that say yes or no. All the operators will be supported to go good on the specific IP. What does it mean? I have to know either the hardware, I have to know all the implication, I have to make architectural choices. And after, I need to know them before, specific, when I'm thinking about my model. And it's not easy. And that's where the role of MLA. We can provide that operator, then level compatibility, a lot other information in terms of model-wise, so global. And we can provide any detection of support partner. I will say before the chain, be ready performance-wise for deployment. It doesn't mean that we are chasing the peak performance. It's not that. It's just that information, the bit of information that usually come later. Now we are trying to bring it earlier. What's coming in 2026? Announced neural technology last year, a SIGGRAPH. It's a neural technology acceleration that goes along with the GPU. So we are expanding from the IoT space, the ETOSU space, to models that can run on GPU and neural technology. Neural technology is specific mostly for graphics and is its own requirement, other essential requirement, and a standardized path. Again, what does it mean? I have model in the cloud that I'm using. I have model on MPU. I have now GPU and neural technology that comes into in play. The same model will be very, very different in each of them. Even from GPU to neural technology, it may go well on GPU and not in neural technology, and vice versa. MLI help here. Area insight, bottlenecks, it's the visual part. The future, we have CPUs, GPUs, we have the MPUs. What we are looking in the future of narrator reaching necessities. And then is when the model, the best model is going to be really difficult. Because the mixed backends and the execution part they will be the normal based. Performance will depend on so many different constraints, memory, data movement between the different IPs. Again, portability of the model doesn't mean portability of performance. How will the MLA will work? So currently we have a single target. We are moving into cross target. So we will have reason, oh yeah, we are going with the GPU with the neural technology, or there's going to be a mix, for example, CPU, GPU, and again accelerator. The report, basically, the future we see that we have more what if, and we will up with this kind of exploration. I have a small demo. I have built MLIA from GitHub sources, so whatever we are public. I'm going to talk, you can watch. So this is our help. There's going to be two commands. One that check is the proper, I want to check performance, I want to check compatibility. We have sub-commands. We have the concept of targets and backends. Targets are the proper IPs. Backends is the software that goes behind them. For example, ETOSU, with Vela or fixed virtual platform. It is called port. I'm showing the two sub-commands. MLA backend, in this case, we have Tricorson and Vela, which is the compiler for ETOSU. I'm showing everything in so I'm at the backend so that I want to try my model. If there's a dependency, yes, it will do everything for you. This is live. So you can see how fast we are going doing this kind of performance check, or how well your model will be on a specific device. Is this all? And now we're going into targets. Targets means that we have an IP, but for each IP we have different variances. It can be types of mux, for example, that in EthosU. For this example, I'm going to use EthosU 85 124 max, but there are way more basically, and there are explanation and everything. So what I'm doing MLIA check specifying the target. In this case, EthosU 20 before, sorry. And then I'm going to specify the backend, the software that I want to run it on. In this case, I'm going to use a fixed method platform. It's called Course 2020. And I have one initial model. It's very simple, 13 layer, just toy model basically. I'm going to check compatibility. The first step is going to run okay. Is going to run on the NPU. Yes. 13 operators, 13 supported. Perfect. Let's go with my performance. I'll add a bit of in the command line. There you go. I have metrics model level, and in the JSON file we also have layer by layer. There's a bit of advanced generation. We are getting better at that. Now that I have all this information, I can have a try, for example, spin up a slightly different model. So I can see that the memory is quite high. 10 operators, 10 supported. Perfect. I'm well on board for Ethos and NPM. Let's go with the performance. It speeds up. Corson is variable. Second table, I can already see that the total cycle are less. So I've done something that is getting, it makes the model better behavior. And this is just in a couple of comments. Sorry? There you go. Okay, I've explained you the story. You've seen a bit of action. What we're going to do in the next future. You've seen that in the slide that in 2026 is coming Near Technology. We have a lot more coming. Near-term focus, more actionable optimization guidance. So the bit of advice that you've seen at the end of the performance, it will get better because currently is a bit slim. We will have multiple input formats. Currently on GitHub, we support just Keras and TensorFlow, but we have more. And I was saying in the slide before, new IT coming. The direction, heterogeneous systems, MLA will help a lot with that because there's going to be a different kind of stacks, a lot of coming. I want to that you basically go away with the concept and ways that it is inference decision at a production also. So we want to move the problem into the runtime. That's the whole concept of MLIA. Of course, across different APIs. And I think that's what I wanted to say. Some links. We have sources on GitHub. We are on 5 so just keep install MLIA. Some learning paths and blog posts. Thank you.